Hello everyone, I am Dr. Kiranmayi, Area Chair and Assistant Professor, Digital Transformation and Operations, Department of Management Studies, School of Business, Aditya University. In this present lecture, I am going to discuss how to solve the linear programming problem using graphical method, a case of unbounded solution. So, in the present lecture, we came to know how to formulate a problem as linear programming problem, and also we have solved the problem using graphical method, and graphical method is used to solve the linear programming problem which involves only two variables. Okay, and a linear programming problem may have different types of solutions. That is, the linear programming problem may have unique solution, or the linear programming problem may have multiple alternative solutions and unbounded solution or infeasible solution. Any of these four situations may exist while solving the linear programming problem. In this present lecture, I am going to discuss a case of unbounded solution. So, here is the problem in maximization model, and we are given two types of constraints. One is less than type, another one is greater than type. The first step in graphical method is to solve the inequalities, to find out the points, to coordinates, to plot the inequalities on the graph. So, the first step is consider the first constraint. The first constraint is x1 minus 2x2 less than or equal to 1. So, consider this inequality as equation. So, x1 plus x2 is equal to 3. So, first put x1 is equal to 0. So, when x1 is 0, x2 is going to be 1.5. Likewise, next time put x2 is equal to 0, then x1 is going to be 3. If we put 0 in the place of x1 in this equation, so x1 is going to be 3. So, when x1 is 0, x2 is 1.5. When x2 is 0, x1 is 3. Therefore, the coordinates for this constraint are 3, 1.5. Okay. So, we have obtained the coordinates to plot the first inequality as 3, 1.5. Okay. And also, if we substitute origin in the given inequality, that is 0, origin means 0, 0. So, 0 plus 0 is 0. 0 is greater than or equal to 3, which is not correct. So, which is a false statement. Therefore, this indicates that the solution space does not contain the origin. The space which does not contain origin will be the solution space. That is the point to be noted here. And also another equation x1 minus 2x2. Here also when we put x1 as 0, x2 is going to be minus 0.5. Likewise, if we substitute x2 0, x1 is going to be 1. And for the first constraint, the coordinates are going to be 1, 0.5. So, this is how first we have to obtain coordinates for the two inequalities. Now, for the first inequality, the coordinates are 1, minus 0.5. Okay. Therefore, let us go to the graph. So, the first coordinates for the first constraint is 1, minus 0.5, right. So, on x-axis it is 1, on y-axis we have to take minus 0.5 lies this side, it is 0.5 and it is 1. So, this is the minus 0.5, right, 1 minus 0. So, this is going to be the line. We consider the solutions place from this because negative values are not considered. Okay. Therefore, this is the line representing the first inequality. The first inequality is of less than type. Less than type means which region we have to consider. So, less than or equal to 1. Therefore, we have to consider this left side region. The region which lies on the left side of the line is to be considered. Okay. And coming to the second inequality. Second inequality is of greater than type. Therefore, so and also the points, the coordinates for the second inequality we have obtained as 3, 1.5 for the second inequality. So, that is second inequality. Here it is 3 and on x-axis it is 1.5. If we join these 2 points, by joining these 2 points, 3, 1.5, we can obtain second constraint. This line represents the first constraint. Okay. So, for second constraint is greater than type. So, for greater than type of equation, inequality, we have to consider the region lies above the line or right side region we have to consider. Therefore, for this inequality, for this line we have to consider this one, and for this inequality, this region we have to consider. Therefore, this shaded region is going to be the feasible region, FR, feasible region, that is the solution space. Okay. From this we can understand that here it is the point A, it is point B, and if we observe the first constraint, it is extended to infinite. So, the other point we cannot touch. The point C exists far away at somewhere at infinite space. Therefore, we cannot locate this point. Therefore, solution space here is said to be unbounded. Okay. The coordinates of the point B are 2, 0.5. And the coordinates for A are 0, 1.5. Okay. Now, we have to find out the value of the objective function at these 2 points of the solution space. So, at A, the value of objective function, this is the objective function given in the problem. So, replace x1 with 0, substitute x2 with 1.5, the value of the objective function is 6. Likewise, the coordinates of the point B are 2, 0.5, and substitute those 2 in place of x1, in place of x2 substitute with 0.5, and the value of objective function is going to be 12. Okay. We are able to find out only 2 points, and the third point we cannot find out. Therefore, here the solution is said to be unbounded solution. Therefore, in maximization problem, if the shaded region is open-ended, this one, so we don't know where, to what extent this line gets extended. So, we cannot locate the other point, third point. Therefore, if the shaded region is open-ended in maximization problem, we consider the solution as unbounded solution. So, this is how we can solve the linear programming problem using graphical method, and this is how we can identify a problem as a unique solution or unbounded solution or infeasible solution. So, in this lecture we have understood how to solve the linear programming problem using graphical method, a case of unbounded solution. Thank you.